Okay, we're doing Converses, section 614. You might have, seen these or heard of these before. They're basically the opposite of something, and they're not always necessarily true. So let's go through the notes. There will be a lot of writing, and I thought of typing this stuff, but because I'm still mic'd up with the computer, excuse me, I also decided against it as well. Okay, here we go. So before we start with converses, I want you to know what a conditional statement is. Let me just actually write it here, because when conditional statements are also called if-then. So a conditional statement is a statement saying, if something, then something. Like, if I'm a dog, then I walk on 4 legs. Something simple like that. If I have $2, then I can buy a hamburger, etc. So it's the condition that this is true. So we'll go through this stuff and make sure it makes sense. If then are written in reverse, I should put in reverse. So if a conditional statement is written in reverse, like in reverse order, so that the hypothesis, this is probably more of a science word, that's the if part. So if you hypothesize something, you say, let's say that I had $2. You're just hypothesizing, right? You're saying then something, something, something. Okay, that would be switched with the conclusion. If I had $2, then in conclusion, I can buy a hamburger, something like that. This new statement is called a converse. My handwriting could be significantly better. I use this calligraphic pen, and it's supposed to make things look all, awesome. Like if that's my signature right there, it should. But if you're doing handwriting, it's kind of weird. Excuse me. Okay, here's an example of a conditional statement versus converse statement. Conditional. You should probably write statement there as well, but that's all right. Okay, the conditional statement. If 2 parallel lines are cut by a transversal, then pairs of corresponding angles are congruent. So the statement says, if I have 2 parallel lines, like this and this, and it is cut by a transversal like that, then we will have any set of 2 corresponding angles like these 2 guys would be congruent, assuming that these are parallel, right? That's part of the if. That's our hypothesis. We make that assumption. We say, okay, if that's true, then this is true. The converse statement takes your hypothesis, your if 2 parallel lines, it makes this part the conclusion. So it switches this statement with this statement here. You have to kind of re-say the words a little bit, maybe, all depending. So check this out. Here's the converse. If 2 corresponding angles are congruent, like this guy and this guy, then the lines cut by the transversal are parallel. So it's saying if we assume this part's true here, then these lines that are parallel, then these lines that are cut by a transversal are parallel. So the transversal makes the congruent angles, and that means if these are true, then this must be true. And I'm not always saying that converses are true, so we're going to talk about that here. Note that just because a conditional statement is true, sorry about the handwriting again, does not mean that its converse must be true. In this case, it is true. Okay, I have 2 congruent angles cut by this transversal. These lines will be parallel. Much the same if I take the converse. If these lines are parallel, I cut it by a transversal, I make 2 corresponding congruent angles. Okay, but it doesn't always mean it's true. And now let me do an example here. I'm going to actually skip this stuff for now, and I'll go back to it because this is more math related, and I want you to make sense of it first. Let's go ahead and, you might have done this kind of thing before. Let's do groups and subgroups. So let's say that I'm talking about modes of transportation. Okay, I can divide transportation into different ways. I can go by sea, land, and air. And within sea, I can be on a boat, I can swim, jet ski, or whatever, right? I can do all those different things. Land, I can go by car, train. Let me separate this a little bit more. Car, train, bicycle, foot, stuff like that. Air, obviously, plane, hot air balloon, you can get really specific. Anyway, moving on. Within a car, right, there are different kinds of cars. There are compact cars, or however you want to divide it. You can divide it by brand at this point, right? You can do whatever you need to. But the thing is, you start dividing this into subgroups. So if I'm going, for instance, by, I hate this thing. Do not show this message again. If, for instance, I'm going by plane, that means that I'm traveling in the air, okay? So a conditional statement would be, if I am going by plane, that means I am traveling by air. Now that's a conditional statement. Would the converse be true? If I'm traveling by air, if I'm going in the air, does that mean I'm traveling by plane? That's not always true. So it works up the subgroups and into the final groups. If I'm on foot, that means I'm going on land, probably not on sea, right? Or in the air. And that means I'm doing a method of transportation. However, if I'm doing a method of transportation, does that mean that I'm going by sea? Or I guess let's stick with the same example. Does that mean I'm going by land? And does that mean I'm going on foot? Not necessarily. Okay. Another way you can put it, for example, in math terms, just to get you started, is if you remember anything about this stuff, let's take the real number groups. Real numbers. Real numbers are divided into rational and irrational numbers. Rational numbers are numbers that can be represented as a fraction, like 3 over 4 or 2 over 1, stuff like that. Like pi is an irrational number. Square root of 3 is an irrational number, right? Anyway, rational numbers can be divided into integers. Integers can be made into whole numbers, etc. So if something's an integer, that means it is a real number. So if a number is an integer, if 2 is an integer, then it is a real number. This is true. Okay? However, if I wrote if 2 is a real number, then it is an integer. In this case, it's true, but it's not always true, right? You have to make sure that you can go from this way to that way. I can't make all real numbers integers, right? 7.9 is a real number, and it's a rational number, but it is not an integer. If it's not an integer, it's not a whole number, etc. So that's all converses mean. And I'm sure I kind of went overboard with these examples, but I want to make sure that you understand you go within subgroups or you come out of them or anything else. So there are real-world examples, and I'll come up with some. For the sake of time, I'm kind of just going to write them and see if you can make sense out of them. So I'm going to the back page, and at the bottom of it, where it actually asks you to make up a conditional statement or arrow diagram that meets the stated conditions, you must use a different example. So I actually want to use real-world examples, and I want to use math examples as well. First, real-world. So here's a real-world example. And I need to do this pretty shorthand. How about a true state? So a true statement whose converse is also true. You want both to be true. How about if I wash dishes, and I'm going to talk about what these arrows mean. They'll make sense in the notes, but it's biconditional. It means it works both ways. If I wash dishes, then they will be clean, right? So dishes will be clean. The converse says, if I have clean dishes, that means I washed them. And I do want to say that that's always true. Obviously, even when you buy new dishes, you still want to wash them beforehand. You want to make sure they're clean, right? Even when you buy them first. So let's say if dishes are clean, that means they've been washed. Likewise, if you wash dishes, that means they're clean. That makes that true. A true statement whose converse is false. So something where this way it works, that way it doesn't. How about, or not always, right? How about something like if your car's out of gas, then it won't run. Right? If your car's out of gas, then it won't run. However, if your car won't run, does that mean it's out of gas? It could, but you can't just specify that, right? A car not running is that major group. Subgroups of won't running are batteries dead, cars out of gas, bad alternator, whatever, things like that, right? There are a bunch of different things. This heater kind of just made a funny noise. Okay, a false statement whose converse is true. So this is kind of one where you might want to start with the thing that you would think about a converse first and then just switch it around. So for instance, let's do a different example though. How about, gosh, I'm already running out of ideas. If I went to a movie, there's the train. Does that mean I paid for the ticket? Probably not. You could have, a friend could have bought it for you. You could have had a free pass. You could have won the ticket. You could have snuck in, right? If you went to a movie, that means you paid for the ticket. No, not necessarily true. However, and I'm going to make this assumption, this is normally what you do, unless you're buying it for your son or your daughter or something like that. If you paid for a ticket, even if you paid for other people, but if you paid for tickets, you probably bought a ticket for yourself, so you probably went to the movie. By the way, I'm talking about movie tickets, not other tickets. If I paid for a movie ticket, I probably went to that movie. But if I went to a movie, it doesn't mean I paid for the ticket. So that's a false statement here, but its converse is true. And a false statement whose converse is false. So kind of think about anything that's just random up in the air, but I want to keep it similar. Okay, I got one. If you are involved in a car accident, then you suffered injuries. Always true? No. Your car might have suffered an injury, right? But you get a fender bender, right? You might not have hurt yourself at all. Okay? Likewise, if you suffered an injury, does that mean you got in a car accident? No, you could have suffered an injury doing anything, right? Hit your head on something, cut something, it doesn't matter. You can suffer injuries anytime, and getting in a car accident doesn't necessarily mean that you get an injury. Okay, so those are examples, real-world examples of conditionals and converses and stuff like that. Let me try and get these out of the way now and do some math ones. And I like I said, I don't want to get so involved in this that you're like, all right, I get it, which you probably do. But math examples, because you haven't seen too many now. Oh, I missed a movie. Okay, a true statement whose converse is true. Excuse me, I do apologize. If, in math, if I have a right angle, that means it's at 90 degrees. I have a 90-degree angle. Okay? If I have a right angle, that means it's 90 degrees. The converse, if I have 90 degrees, that means I have a right angle. Are both true? Yep. Both are indeed true. Okay, let's look at a true statement whose converse is false now. If we're looking at a triangle, that means we're looking at a polygon, right? All triangles are polygons. A polygon's just one of those enclosed shapes, right? But are all polygons triangles? No, right? You work from the subgroup, and you work from the major group. You divide into subgroups. A polygon could be a square, a triangle, a pentagon, hexagon, anything else like that. Not necessarily a triangle. False statement whose converse is true. Trying to stick with triangles here because that's the thing we're in. If triangles are similar, does that mean they are congruent? That's something you have to be careful of. Triangles are congruent. No, I mean, we've talked about this before. If triangles are similar, you need a side ratio of 1 for each to say that they're congruent. However, if triangles are congruent, that means they do all have same side ratio, so therefore they are similar. Right? And then false statements, converse is false. I'm going to kind of get ridiculous here. Triangles have, no, triangle, if we're looking at a triangle, that means we're looking at a four-sided shape. but obviously it's not true. Triangles do not have four sides. They're not four-sided shapes, and four-sided shapes are not triangles, right? So that's a pretty obvious one. But that's not really good if then. I'll come up with a better example, hopefully in class. So anyway, I just want to make sure that those things make sense. I'm kind of extending it onto math. So now you can look at a bunch of different examples here. We're going to go back to the first page and look at everything that we talked about. And I don't really want to do all of these. I want you to make sure that you kind of get them too. I'll get you started here, and I'll do one example, and you kind of do the rest. They kind of make sense. So if two parallel lines are cut by a transversal, we kind of talked about this, then pairs of corresponding angles are congruent. Okay, two parallel lines are cut by a transversal, and pairs of corresponding angles are congruent. Now we gave the example and everything else. I think it was up here, right here. All right, and it's right there as well. Let's go and write that inverse, just like it is up here. If two corresponding angles are congruent, then the lines cut by the parallel are, cut by the transversal, that didn't make sense, transversal are parallel. Okay? Here's the regular conditional statement, here's the converse. Now it's up to you to decide whether or not the converses are always true. In this case it is, but you have to check all of them, and we're actually going to do that on the back. I'm going to come up with these things for you to make sure that you know what we're talking about here based on what the things say, right? You have to make sure you write the correct thing. So if two parallel lines are cut by transversal, then pairs of vertical angles are congruent. Okay, that would make sense. They don't have anything else like interior and stuff, right? Supplementary aren't necessarily true either. So write the converse for yourself. If two parallel lines are cut by the transversal, then pairs of blank interior angles are congruent. Well, same side interior angles are supplementary, so I'm guessing we're talking about alternate interior angles here. Again, write the converse for yourself. If two parallel lines are cut by a transversal and the pairs of blank interior angles are supplementary, that's what I just talked about, that would be same side interior angles. And if two parallel lines are cut by a transversal, then pairs of blank angles are supplementary. Well, I would say same side exterior angles, but it doesn't say exterior here. I'm guessing they're going for adjacent angles. And adjacent angles are those ones that are like these two guys right here. And if we're talking about two parallel lines cut by the transversal, talking about these angles 1 and 2. Those are supplementary. So go ahead and write the converse for that one as well. Moving on over, biconditional statements. We just did these down low, and we're going to fill out the rest of this uber quick. Want to make sure it makes sense. Biconditional statements means that it works both ways. You have the conditional statement and the converse. They both work true. Okay, arrow diagram. So if and only if using the previous side. So let's see, what did we have here? We had to, you're just doing it without writing if then. So the first one, if two corresponding angles are congruent, then the lines are cut that are cut are parallel. So I want to kind of keep them whatever. So sorry, that was the converse that I said out loud. Two lines cut by transversal are parallel. So if they're parallel, then corresponding angles congruent, right? All these are the same. If they're cut by transversal and parallel, then. And then we had, I believe they were vertical angles congruent. Okay? And then I think we said alternate interior angles congruent. And then we said same side interior angles. Whoops. Same side interior angles congruent. Again, hopefully you're just listening so you don't write exactly the slop that I'm writing. You probably don't even understand this. And finally, adjacent, I'm sorry, these aren't congruent. These are supplementary. See, that's why you don't want to write what I write. And adjacent angles are supplementary. Okay, now it says if the biconditional statement is not true, put an X through the arrow. So you have to think about these a little bit. Let's go ahead and draw these lines up here again. I have two lines. I assume they're parallel because that's this part right here. Okay. Now, in order to prove it false, you have to prove it false by counterexample. You want to give an example that doesn't make it true, if you can. In the first case, number 1, I can't make that untrue. If corresponding angles are congruent, these two lines must be parallel. Let's go ahead and do that. Okay. Vertical angles. If vertical angles are congruent, so let's look at this set of green guys right here. Let's do this guy and this guy. If vertical angles are congruent, now here's the thing. We go from these lines cut, whatever, but we're only referring to this set of lines. We're not even referring to this line here when we talk about vertical angles. So vertical angles being congruent doesn't really have anything to do with this, but that doesn't make that untrue when you say this, right? If this, then that is true. But if I say vertical angles are congruent, does that necessarily mean that this line is parallel with this line? I mean, I'm not even talking about this line, right? This line could look like this for all I know, and for all I care. That doesn't make these vertical angles not congruent. So this is not biconditional. Okay? This one does not work both ways. I can only do it from this way to that way. So see if that kind of thing makes sense to you when we do these. Let me pick more colors to work with. Okay, alternate interior angles congruent. Let's work with yellow. That would be, for instance, I only have so much to work with. This yellow. Yellow is probably a bad color. This guy and this guy. If alternate interior angles are congruent, I'm sorry, if lines are cut by a transversal that are parallel, then alternate interior angles are congruent. That's true. The converse, alternate interior angles are congruent. Does that mean that the lines cut by the transversal are parallel? It does. You can try and come up with a counterexample. Try and figure out ways that it wouldn't be true, but I'll tell you now that that's true. We're kind of referring to the ones that don't affect both lines. Same side interior angle supplementary. We use black here. These two guys, this guy and this guy being supplementary, again, also mean that the lines cut by the transversal are parallel. The converse here does work. Okay. And finally, if I have adjacent angle supplementary, so like this red guy and this red guy, they're supplementary, does that mean that this line and this line are parallel? Again, we're not referring to this line at all. The fact that we drew two lines and cut it by a transversal and said they're parallel, we'll say that these are supplementary. That has nothing to do with this. But going the other way does not make sense. Saying that this has to be that way. It could look like that, like I said, and these will still be supplementary. So this is false. Well, not that it's false. This way works, but this way doesn't. It is not biconditional. Just one way works. Okay, and finally, determine if the conditional statement given by each arrow is true or false. Write the converse of each statement as an arrow diagram, and determine if the converse is true or false. So, basically, we have the conditional here. We'll write the converse as a conditional, switching these around, and we'll say whether they're still true or false. If triangles are congruent, then their corresponding side lengths are congruent. This is true. This is a part of CPCTC. Right? We've justified this. Triangles are congruent, their corresponding parts of congruent triangles are congruent. That's true. If corresponding side lengths are congruent, does that mean that triangles are congruent? So we're switching. I'll just write triangles. Triangles are congruent. So does the converse work? Yes, it does. If all of them, all the corresponding side lengths are congruent, the triangles are congruent, yes, that's the side-side-side congruence theorem. Right? We know that one. Side, side, side. If triangles are congruent, corresponding angles are congruent. This is also true, of course, because CPCTC. Corresponding parts of congruent triangles are congruent. So if corresponding angles are congruent, does that mean that triangles are congruent? Can we use angle, angle, angle? I should have wrote that over here. Can we use angle, 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 or angle, angle to say that triangles are congruent? We can use that for similarity, but we cannot say that for congruence. False. Right? They can be big or small and still have the same angles. Finally, a shape is a rectangle means the area of the shape is base times height. This is true. All rectangles have area base times height. However, is anything that I compute base times height a rectangle? think about it. You might have to know formulas, but the area of a parallelogram is base times height. The area of a rhombus is base times height. I can't really think of other ones, but not all, and squares, right? But that's kind of side squared. So shape of rectangle, area, true. Area base times height is the shape of rectangle, not necessarily. It could be a parallelogram, rhombus, or square, which is a rectangle. So false. Okay, and that's all I got on Converses. That seems like a lot, actually. A lot of explanation. I'm just kind of trying to get the logic in and make sure that all makes sense. Not everything works in the backwards way, working from group to subgroup. All right, ask questions if you have them.